Everyone. So in order to solve this question, I want to look at an example. So I just randomly chose a number. I chose 18, and I did two factor trees to find out the prime factors of 18. And I found that they were 3, 3, and 2. So 18 is equal to 2 times 3 times 3, or we can also write it as 2 to the power of 1 times 3 to the power of 2. Now what I want to show you is that if we choose any factor of 18, it will be a product of a certain number of 2's and a certain number of 3's. In fact, I want to show you that it'll be a factor of 0 or 1 2's or 0, 1, or 2 3's. Let me explain. So let's take 9 here, for example. 9 is a product of 3 and 3, so 2 3's, but 0 2's. 6 is a product of 1 2 and 1 3. 3 is a product of 1 3 and no 2's. I hope you're starting to see what I mean, so let's move on to the question. How many factors does this number n possess? Well, we don't have to go in and calculate what that number is because it's going to be very long, but let's write it out a little bit bigger so we can see it. We've got 2 to the power of 3 times 5 to the power of 2 times 7 to the power of 4 times 11 to the power of 1 times 19 to the power of 2. So if you think about it, any factor of this number here is going to contain 0, 1, 2, or 3 3's. It's going to be a product of 0, 1, or 2 5's, and 0, 1, 2, 3, or 4 7's. It can only be a product of 0 or 1 11's. And finally, 0, 1, or 2 19's. So what are we working with here? For the 2, we have 4 choices. For the 5, we had 3 choices. For the 7, we had 5 choices. For the 11, we had 2 choices, and for 19, we had 3 choices. So let's multiply this lovely number together, and we get 360. So that is how many factors this huge number here could possibly have. Now the second part of the question asks, what if we have n squared? How many factors does n squared have? Well, I'm just going to copy this number that we wrote down. So if that was n, and we now want to observe n squared, n squared will look like this number squared here. So we'll have to apply an exponent of 2 to everything inside the brackets. So instead, we can rewrite this as 2 to the power of 6 times 5 to the power of 4 times 7 to the power of 8 times 11 to the power of 2 times 19 to the power of 4. So for the 2, I have 7 options because I can have a product of 0, 1, 2, 3, 4, 5, or 6 2's. So there's 7 options there. For 5, I have 5 options. For 7, I have a possibility of 9. For 11, we have 3 choices, and for 19 we have 5. And this lovely number is 4,725. So notice how it was not just 360 multiplied by 2. We had to think about it. So that is how many different factors n squared would have.